Application of differentiation. Introduction of differentiation. Differentiation is the one method that we use to finding the derivative and the rate of change of a function, which is fx. There has many types of differentiation that we always use to solve the maths problem. As example, they had the definition of differentiation, which is the first principle of differentiation. The basic algebraic function for derivative is dx to the power of n equal to nx to the power of n minus 1. We must remember the derivative of standard function when we want to use the differentiation method. When we differentiation of function, it should be f prime x or dy over dx. In differentiation, we also have the derivative of logarithmic function and exponential function. We use the chain rule, the product rule which is uv prime plus vu prime, and the quotient rule which is vu prime minus uv prime over v square to solve the problems too. They has application of differentiation such as related rates and to apply maximum and minimum problems. We use related rates in differentiation to find the relationship between the variables that are changing over time, and the applied maximum and minimum problems which is a vital application of differentiation.
Question 1 is, a conical water tank has a radius of 4 cm at the top and 60 cm of height. Water flows into the tank at a rate of 8 cm³ per second. Okay, question A, show that the volume of water is given by V equals to 1 over 48 pi h³. So the question asks to prove the volume given. So this is the illustration of the question. 60 cm of height and 4 cm at the top, but the height and the R of the water flow is unknown, so we have to figure it out. So the first step is let R equals to 4 equal H equals to 16. So rearrange the R, make it as a subject, therefore equals to R equals to H over 4. So as we all know, volume of cone is equals to 1 over 3 pi R squared H. Let 1 over 3 pi R squared H equals to 1 over 3 pi. Insert the R value that we got from the above that we have arranged, which is H equals to 4 into the R here time H. So 1 over 3 pi H squared over 4 times H equals to 1 over 48 times pi h³. Proof. The volume is proof. Let's move into question B. How fast is the height changing at an instant when the height of the water is 4 cm? So the question already give the information of dv dt, which is equals to 8 cm³. So let's make dh over dt equals dh over dv times dv over dt. So in order to find dh and dt, we have to figure it out dh over dv. So how to do dh over dv is by differentiate the volume. So dv over dh equals to 3 over 48 times pi times h squared. So that is not complete yet because we want to find dh over dv. So what do we need is to after changing dv over dh into dh over dt, the answer will become 48 48 over 3 times pi times 4 squared. So therefore dH over dt equals to 1 over pi times 8. Thus the answer is 8 over pi centimeter cube per second.
Okay, next I will explain about the question 2. So a cylindrical can has a radius of r cm and height r plus 4 cm. The can is expanding at a constant rate of 5 cm cube per second when heated. So the hint given is the volume of cylinder is equal to pi r squared h. So A, show that the volume of the can is given by V equal to pi r cube plus 4 pi r squared. To solve this question, we have the information which is the radius is r cm and the height is r plus 4 cm. So we just need to substitute the information into the formula volume of cylinder, which is pi r squared h. So after we substitute the information given, we will get the pi r squared bracket r plus 4. So we need to expand the bracket and then we will get the pi r cube plus 4 pi r squared. B. How fast is the radius changing at the instant when the radius is 3 cm? To solve this question, we have the information which is the radius is equal to 3 cm, the dV over dt is equal to 5 cm cube per second, and we need to find the dr over dt. So first thing first, we need to differentiate the volume of cylinder that we get from the question A, and we will get the dV over dr which is 3 pi r squared plus 8 pi r. Then to find the dr over dt, we need to times the dr over dv with the dV over dt. The value for dr over dv is 1 over 3 pi r squared plus 8 pi r times with 5. So we substitute the value of r, which is 3 cm, into the equation, and then we will get 1 over 160.22 times with 5. So we calculate the formula and then we will get the answer is 0.0312 cm per second. Conclusion. In conclusion, we use and learn differentiation to aid in our knowledge and to use in everyday life. What we learn from differentiation and application of differentiation, we can understand the idea of differentiation from first principle until the last one, which is quotient rule. We can differentiate the function properly and can also understand the solution of derivative as rate of change in calculus 1. References. Here are the references that we use. Thank you for watching.